So yesterday we learned how you solve systems of equations graphically and by a table. You probably found that those are not very efficient ways. Probably the most efficient ways are the ways we're going to look at today, and we're going to look at something known as substitution and elimination. Before I get started, let's review a little bit from what we did yesterday. So it says to graph each system of equations and describe them as consistent and independent, consistent and dependent, or inconsistent. So refresh my memory as to how I would start this problem. Yep, I would do the ABC. And so here, I end up getting my slope to be what, folks? The negative of -2 over 5. So my slope here is 2/5. Now remember to find the y-intercept. What was the y-intercept?
C over B.
C over B, so 10 over 5, which is 2. So I would come here and put a dot at 2. Then I'm going to go up 2 over 5, up 2 over 5. Okay, so now what I need to do is go ahead and draw my line in. And there we go. So there is my line. So now I need to figure out my slope here of my next line. What's my slope of my next line going to be? -4 over -10. What does that reduce down to?
-2/5.
Yep, 2/5. Okay, so notice they're going to have the same slopes. What's my y-intercept going to be here?
2.
-20 over -10. So my y-intercept here is 2. Oh, so here's 2. Up 2 over 5, up 2 over 5. What do you notice about the blue line? It's the same as the purple line. So do we remember what we called this?
No solution.
This is the consistent and dependent because it has infinitely many solutions. In order for it to be the inconsistent, you would have had to have a line up here that would have been parallel to the purple line. But since this is the exact same line as the given one, your solution is consistent and independent, and your solution is actually all real numbers. All right. So now what we're going to do is we're going to look at not graphing. We're going to look at how you solve this algebraically. And so if you notice it says to solve the following system using substitution. So once again, I could graph this and get a solution. Problem is, if I were to graph this, you're going to notice that the y-intercept in the first problem is going to be a fraction. So anytime you have fractional values, it's hard to find a specific point. So we're going to use something known as substitution. For substitution to work, you need to find a variable that does not have a coefficient or has a coefficient of 1. So do we have a variable there that has a coefficient of 1? Which one? Y. So I want to solve for this y. I want to get the y all by itself. So what are you going to do? Minus 2x. Good. So I end up getting y to equal 7 minus 2x. Do we remember now what we do?
You plug it in.
Yep, we take 7 minus 2x, and I'm going to plug it right in here for y. So you're going to go to the first equation that we haven't used yet. You're going to plug in 7 minus 2x. So I end up having 5x minus 3 times 7 minus 2x equals 23. What I need to do now is do what?
Distribute.
Distribute. So I'm going to distribute here. So I end up getting 5x minus 21 plus 6x. For those of you wondering where the plus came from, this is a -3. So you're taking -3 times 7 and -3 times -2x. Okay, now what we need to do, let's add some like terms together. 5x and 6x is how many x? 11x. So I have 11x minus 21 equals 23. What do you do to solve that?
Add 21.
You add 21 to both sides. So you end up getting 11x to equal 44. Very good. Next step is to divide by 11. So what does x equal? 4. Very good. So now what I'm going to do is I'm going to take that 4 And I'm gonna come back here and I'm gonna plug it right in here for x. And that will tell me what my y value is. So I end up having 7 minus 2 times 4. Well, what is 2 times 4?
8,
So I have 7 minus 8, which is
-1.
-1. So my solution is the ordered pair for -1. Now remember again what that means. If I were to graph these two lines, just like I did from yesterday, they would intersect at the point for -1. So this would be called what kind of system? Yeah, consistent and what else?
Dependent.
How can you tell just from the
Consistent.
ordered pairs that if it's consistent with?
This one will be consistent and independent because it's only intersected at one point. There's only one solution. So that's how you know. It will be inconsistent if there's no solution, and it will be consistent and consistent and dependent if it's all real numbers. And we'll keep looking for one of those. Okay. All right, so let's go through this one. -6x minus y equals 27, and 3x plus 8y equals 9. So once again, we're going to look to substitution today, right now. So what variable do you think you're going to solve for?
Y.
The first y, yep. Now, so the first thing I'm going to do then is add 6x to both sides. So I end up getting -y equals 27 plus 6x. But I don't want to solve for -y. I want to solve for positive y. Yeah, divide by a -1. Or what I could do is just switch both sides. So I end up getting y to equal -27 minus 6x. Okay, I want you to go ahead and try and finish this problem. I'm going to walk around and check on you. I'm going to keep putting little steps on the board, so if you get stuck, you can look up on the board and see if that can kind of help you a little bit.
Are we supposed to get a decimal for tomorrow?
A decimal? You think? you should see that your solution here is -5, 3. Now, one of the things you're going to notice, if you forget a negative sign at any point in the problem, it's going to throw you off. Okay, I saw a lot of people miss this negative sign right here. That kind of threw you off. The other thing is, up here, this is a minus a negative, which makes that a positive. So anyway, that's the only downfall with this way versus the graphing way. Do you think you have substitution down? Do you think we need to look at another one?
Nope.
Okay. Well, now we're going to talk about elimination. Now, elimination is actually my favorite of the two. The reason being is that elimination works with every type of system of equations. Substitution sometimes can get kind of messy. Because if you were to use substitution here, what variable would you solve for?
You wouldn't.
Yeah, I mean, any variable you pick, you're going to have a ton of fractions involved. And so that's why elimination works well. Now for elimination, this is what you're looking for. You're looking for either the x's or the y's to have opposite signs. Do you notice any of the x's or y's that have opposite signs? Yeah. The y's here have opposite signs. The other thing you're going to notice about the y's is that they are the same number, just with a different sign. So ideally, this is a perfect elimination problem because our goal is to eliminate a variable. And if I were to add these two equations together, what variable could I eliminate? The y. Because if you add 4x plus 2x, what do you get? 6x. If you add negative 3y and positive 3y, what do you get? 0. It's gone. And so then, now I'm going to add negative 22 and 16. What is negative 22 and 16? Negative 6. So now all I need to do is solve this for x. So I'm going to divide both sides by 6. And what do you get x to equal? Negative 1. So now all we need to do is find the y. And this is the only problem with elimination. It's not as neat to plug your value back in. And so I can either plug it into the top equation or the bottom equation. I'm going to choose to plug it into the bottom equation. The only reason is that I notice the bottom equation doesn't have a lot of negatives like the top equation does. And sometimes we make mistakes with negatives. So all I did is plug x equals negative 1 in for x right here. So 2 times negative 1 is negative 2 plus 3y equals 16. In order to solve that now for y, I'm going to add 2 to both sides. And I end up getting 3y to equal what? 18. Divide both sides by 3. And what do you get y to equal? 6. So my solution will be the ordered pair, negative 1, 6. So in some cases, elimination can be a little faster than substitution. Let's look at another one. Oh, sorry, I skipped through that one awful quick. Let's go back. There we go. Now, if you look at this one, remember our goal was to have one positive, one negative. Yeah. We got 2 positives and 2 negatives, but we don't have any alternating signs.
Well, you skipped this.
The neat thing about elimination is that you can change the problem by either multiplying or dividing by numbers. So what I could do in this problem, because ideally if one of these was a positive 5y, that would be great. So to make this a positive 5y, I'm going to basically multiply by a negative 1. And when I multiply by a negative 1, that just changes every sign. So all I did there is multiply by a negative 1, and notice how it changes the signs? Now I can go ahead and eliminate y. So 6x minus 4x is what? 2x. What does that equal? 4. Divide by 2. What do you get x to equal? 2. So now all I need to do is plug that in. It doesn't matter. You can plug it into one of the originals. Anyway, I'm going to get 6 times 2 minus 5y equals negative 8. So 12 minus 5y. Let's go ahead and subtract 12. I end up getting negative 5y equals negative 20. What do you do now? Divide by negative 5. What does y equal? 4. So your solution is?
Which equation did you use?
I used the bottom one. Or no, I used the top one. I take that back. Now, if you use the bottom one, you'll get the exact.
I got
It's negative
18
4
too.
times 2. Oh. Okay. You can use either equation. You'll still get the same answer. Okay. So far, you like elimination better?
Yep.
I usually do. Now we got a problem here on this one. Yeah. Problem number 1 is that I don't have a positive and a negative. Problem number 2, I can't make one of those negative and just add them together and eliminate a variable.
So what do you do?
Okay, now the last problem we multiply by negative 1. What we're going to do here is have to multiply by another number, okay, whether it be a 2, a 3, a 4, whatever. So what variable do you want to eliminate? Do you want to eliminate x's or do you want to eliminate y's? Y, okay. If I look at the y's, I've got a positive 3 and a positive 9. I need to somehow get those the same number with opposite signs. So what number do both 3 and 9 go into? What number do 3 and 9 both go into?
Oh.
They go into 18. Let's think a little smaller. Don't they both go into 9? Okay, 3 goes into 9, right? What times 3 gives me 9? 3. And I'm going to make this a negative 3. So that way I make that negative. The bottom equation, I don't have to do anything to because it's already a 9. So the top equation now becomes negative 6x plus negative 9y equals negative 15. My bottom equation is going to stay the exact same. So now we need to add both of the equations together, right? So if I add them both together, I get negative 6x positive 6x, which is 0. Negative 9y positive 9y, which is, so I end up getting 0 on the left. What do you get on the right? 0. Is this a true statement?
No.
Does 0 equal 0? Yeah. This is a true statement. Since this is a true statement, this is going to be your solution. It's going to be all real numbers. Now let's think about that. Think about the graphs. What type of lines would these be? They would be the lines that would be one on top of the other. This is just like the very first example we looked at today. Okay?
Neat.
Yep, so this one would actually be consistent and dependent. And this is a line. If I were to graph this, it's going to be the same line. Alrighty. I want you to try this one. Okay? I want you to try this one. See if you can come up with a good start.
Can you divide both lines by a number?
You mean multiply?
Yeah.
Yeah.
Or, yeah, that's
Yes, you can. And in fact, that's what you're going to have to do here.
Does it have to be the same number?
No, it does not. So if you didn't catch, first of all, Parker asked if you can multiply each equation by a number. The answer is yes. Okay. Laura then just asked, does it have to be the same number? And the answer is no.
It just has to make the variables.
It just has to make the variables opposite so they can be eliminated. So you can
Which
multiply
number
the
is
top equation by one number, multiply the bottom equation by a totally different number,
Oh.
and then you can eliminate a variable.
Didn't we do this last year?
Yep. So those of you that are stuck, okay, what would be a good variable to eliminate? The y, because it has opposite signs. So now I need to think I've got the number 3 and 2. What do both 3 and 2 go into? Smallest number. 6. So how do you get 6 from 3? You multiply that by 2. How do you get 6 from 2? What do you have to multiply 2 by here? 3. There you go.
Oh, I got a crazy decimal.
Oh, you got a crazy decimal?
Yeah, I did too.
Yeah,
You can get crazy decimals. I don't know if you
No,
should have gotten
you're
that
not.
crazy. Okay, this comes out to be 16x.
Oh.
This comes out to be 15x. So I end up getting 31x.
Am I right on this one?
Wait, so then if,
Oh, I subtract.
so when we get our x, do we plug it into?
Plug it back into one of them. It doesn't matter which one. Either you've got 4 equations.
No, like
You
one of
can plug
these
it
or
in
one of these?
here, 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 or here. It doesn't matter.
Cool.
I still got a decimal.
Okay, first of all, 2 times a negative 11 is negative 22. So now this is 2 times 11. It's not negative. So then this is negative 30.
Oh, yes, I did.
You get y equal one. No, y.
Okay, I went ahead and showed the steps I went through to find x. Now, which equation do I plug negative 1 into? Which equation? It doesn't matter. You've got 4 different equations you could plug it into. You could plug it into this one up here, you could plug it into this one, you could plug it into this one, or you could plug it into that one. It doesn't matter. Okay? I'm looking at the problem, I'm going to plug it into the bottom one. Why? Because that one, to me, doesn't have a negative 3y. Okay? I try to stay away from the negatives if I can. So 5 times negative 1 is negative 5, plus 2y equals negative 3. What you need to do now is add 5 to both sides. And you should get 2y to equal 2. Now what you need to do is divide both sides by 2, and you get y to equal 1. So your solution here is negative 1, positive 1. Now this is our goal for today. Okay, I'm going to give you a book assignment. I think I have, yeah. I'm going to give you a book assignment right here. Page 142, 43 through 58, the evens. Now tomorrow, we're not going to go on. You're going to do more substitution and elimination. Okay, more substitution and elimination problems tomorrow. You're going to have a quiz on Thursday. So you're going to have a quiz on Thursday. So that's kind of the plan for the next few days. Questions? No, it'll just be over the substitution and elimination. So.